Alright, so now we're talking about angle bisectors and how they interact with a triangle. So when you think about an angle bisector, the angles are always equidistant. So like AP will always be equal to that line AX and so AB and AC. It'll always be equal to those two lines, that distance. Okay, so as this line comes out, everywhere on that line is equidistant from the sides. Okay. Now, as the angle bisector of C comes out, it will be equidistant from the side AC, and it's equidistant from the side CB. Now, again, using the converse to the angle bisector theorem, we can say that because this point is already equidistant from all three sides, then if the angle bisector of B also intersects that point, then it will be equidistant from BA and BC. So because that point is on AP, that any point on that line will be equidistant from the two sides AB and AC. Any point on the line CP will be equidistant from the sides AC and BC. Through those two, we've covered the entire triangle. And it just means that the third line is kind of redundant. Of course it's going to fall on the same point because they have to be. Alright? So the point of concurrency of the angle bisectors is called the incenter because it is inscribed inside of, because this is the circle that is equidistant from all the sides. Now, incenter is always inside the triangle because it is always equal distance from all the sides of the triangle. It's kind of cool that way. Okay, and remember that we create this by cutting angles in half. So we are equidistant from sides by cutting angles in half. And then the circumcenter we found by cutting sides in half. And it was equidistant from the angles. Right? Or the endpoints of the line. Okay, so circumcenter goes to perpendicular bisectors. Incenter goes to angle bisectors. Yes, you actually need to remember those two and their differences because it's part of it. Okay, so right here we're given a bunch of information. It says that QN, so this line, is 5x plus 36. That's interesting information. It also says that QM is 2x plus 51. It wants me to find QO. Alright, and we're going to be able to do this because if you notice, Q is where the angle bisectors meet. So that means that all three of these have to be equal. Well, if QM and QN are equal, then we can say that 5x plus 36 equals 2x plus 51 because Q is the incenter. And the incenter is equidistant from all the sides of a triangle. Okay, so now we're going to subtract 2x from both sides. And I get 3x plus 36 equals 51. Then I'm going to subtract the 36 from both sides. And I get 3x equals 5, 15. Okay, and then I divide both sides by 3, and I get x equals 5. Now I have x equals 5. Is that the distance of Q? Oh, no. So all I have to do from this point is choose one to plug it into. I'm going to plug it into 2x plus 51. So this is going to be 2 times 5 plus 51. Is 10 plus 51 is 61. So the length of QO is 61. Alright, we were able to do that because it was the angle bisectors that met that are equidistant from all the sides. Okay, now you're going to name each point of concurrency, or name the point of concurrency of the angle bisectors. Only one of those letters is where the angle bisectors meet. And then on number 5, you're going to find the value of x. Okay, so look at the pictures, see what you can tell about those RS and RT. And then once you finish those two things, you're done for the day. Please write a recap and you are good to go.